Class, in this video we begin our discussion on section 4.5 in your textbook dealing with exponential and logarithmic equations. So here on page 1 of your lecture handout we're going to begin solving some exponential equations. And so you're instructed to solve each exponential equation for the variable x. So in our first example we have the exponential equation 5 to the 2x is equal to 5 to the x plus 1 power. Well, the exponential on the left and the exponential on the right have the same base, so if the bases are equal, then the exponents must be equal. So the exponent 2x on the left has to equal the exponent x plus 1 on the right. And so now this is just a linear equation. And when we solve for x, right, we subtract x from both sides and we get x is equal to 1. So the solution to this exponential equation up here is x equals 1. And you can see that when you put in 1 in for x on the left hand side, we have 2 times 1, which is 2, in the exponent. So the left hand side is equal to 5 squared. And when we put in 1 in for x in the exponent right hand side, we have 1 plus 1, which is 2, and so the right hand side equals 5 squared. So we have 5 squared is equal to 5 squared. In the next example, we have the exponential equation 7 to the 2x minus 3 power is equal to 7 to the 6 plus 5x power. Again, the exponential on the left and the exponential on the right have the same base, so because the bases are equal, the exponents have to be equal. So the exponent 2x minus 3 has to equal the exponent 6 plus 5x. And so when you set them equal to each other, right, that's just a linear equation in the variable x. And so we just solve for x, right? Subtract 5x from both sides, add 3 to both sides, and we get minus 3x is equal to 9. Divide both sides by minus 3, and we get x is equal to negative 3. So x equals minus 3 is the solution to our exponential equation up here. If you put in minus 3 in for x, and the exponent on the left hand side, you have 2 times minus 3, which is negative 9. And on the right hand side, when you put in minus 3 in for x in the exponent, you have 6 plus 5 times minus 3, which is also minus 9. And so minus 3 put in for x makes the left hand side equal to the right hand side. In the next example we have the number e. Remember, e is that special number in mathematics. It's equal to 2.718 to 3 decimal places. So we have e raised to the 1 minus 2x power is equal to e raised to the 3x minus 5 power. Again, exponential on the left, exponential on the right. The bases of the two exponentials are equal, so the exponents must be equal. So the exponent 1 minus 2x has to equal the exponent 3x minus 5. And now, again, that's a linear equation in the variable x, and we just solve for x. Subtract 3x from both sides, subtract 1 from both sides, and we get minus 5x is equal to negative 6. Divide both sides by negative 5. And we get x is equal to 6/5. So 6/5 put in for x and the exponent up here on the left, and in for x and the exponent on the right will make the value of the exponent on the left equal to the value of the exponent on the right. And then lastly, we have 10 raised to the 2x minus 3 power is equal to 1/10. So this is not an exponential on the right hand side the way it's written, but we know 1/10 is the same as 10 to the minus 1 power, right? Remember, the negative sign in the exponent means reciprocal, so 10 to the minus 1 is the same as 1 over 10 to the plus 1, or 1/10. So 1/10 is equal to 10 to minus 1. And now we have the exponential on the left and the exponential on the right have the same base, and so their exponents must be equal. The exponent 2x minus 3 must equal the exponent minus 1. Now again, this is a linear equation in a variable x. We just solve for x. Add 3 to both sides, we get 2x is equal to 2. divide both sides by 2, we get x is equal to 1. So x equals 1, right, is the solution to our original equation. If you put in 1 in for x in the exponent, we have 2 times 1, which is 2, and 2 minus 3 is negative 1, and so we have 10 to the minus 1 is equal to 1/10, and that's a true statement.